So now that we finished the problem number, let me flip the page. On page 339, 9.6 example. So now you can guys work through the rest of the problems, pretty much using the same approach by, as we learned before, just converting. If you got a given unit times, always in the bottom you guys are going to put a given unit, and then desired unit, and the desired unit, cancel, cancel. So at the end, you always get your desired unit. And that's exactly what we did, guys, in the previous problem where we had the units that were given moles. So we put 1 mole equivalent to number of molecules, and then the reason we use that conversion factor because that's what the question was asked, is how many molecules of CO were in that particular number of moles. Now, we're going to move to the next topic, which is the, on page now, guys, the textbook 341. 341. And the topic here is the mass of a mole. Mass of a mole. Okay. So it's a pretty straightforward topic. Now, remember I gave you guys again, I'm going to position here our 2 conversion factors of a mole. 1 mole is always the Avogadro's number. And then 1 mole is pretty much what's called a molar mass. Molar mass. And so now what we're going to do is we're going to talk about the molar mass, which is nothing else as the mass of a mole of a substance. And remember, guys, the substance can be of 2 types. It's a pure, pure substance is an element. And of course, it is a compound. So when we're discussing the molar mass or mass of a mole, we pretty much determining the molar mass of an element or a compound. All right, how do you do the element molar mass? Just look it up. Look it up in the periodic table. For example, if I say 1 mole of oxygen, how much would that be? Well, you have to look up in the periodic table and see, well, oxygen is 1 oxygen is 16.00 grams. Now you see I'm using grams here for molar mass. But if you actually talking about 1 atom and mass of 1 atom of oxygen, then we of course use units as 16.00 AMU. So the mole and the AMU units pretty much have the same magnitude, but different units because they represent different masses, of course. This is just mass of 1 atom of oxygen, okay? And this one is the mass of 1 mole of atom of oxygen. This is the mass of 1 mole of atom of oxygen, or oxygen atom, of course. Okay, now, but as you can see, this is not an atom, this is a molecule. So therefore, you have to say 2 times 16.00 grams will give you the mass of 1 mole of oxygen, which will be, of course, 32.00 grams. Okay, and that will be nothing else as 1 mole of oxygen, and that will be of O2. And again, how did I get it? I look at the periodic table, and then I just, so oxygen is 16, but that's 1 atom, and I mean that's 16 grams for 1 mole of mass of oxygen atoms, but these are molecules here, so you have to make sure that you multiply by as many molecules as there are in the formula to get the molar mass of the substance. I'll give you another example. Let's say I need the molar mass of carbon atom. Let's say carbon atom. carbon molar mass. Since copper by itself, we're looking at, let's say, all you have to do just pick it up from the periodic table itself and say just 12.01 grams. Again, this is molar mass of carbon atoms. All right, what about, let's say, argon? Again, you look it up in the periodic table. Argon is a noble gas by itself, and that would be 39.95. 39.95 grams, etc., etc. Now, what about the compound? Compound, pretty much we do it the same way as we did with the atomic mass units, but again, we did it for determining mass of one molecule. Now we're getting the molar mass of Avogadro's number of these molecules, and as a result, let's say I have a substance CO2, and we need to get the molar mass. All you have to do, again, look at the periodic table, get the mass of carbon that will contain 1 mole. In this formula of carbon is 12.01 grams of carbon, and you got 2 moles here of oxygen, so you're going to do 2 times 16.00 grams of oxygen, and then you will have to add these grams, and I'm going to do it right here. It's going to be 44.01 grams of CO2. So in other words, molar mass of CO2 is equivalent in terms of grams, 44.01 grams. Okay? So again, the mole unit can have, of course, there's a number of items in it, and that's how it's defined. And the mole, of course, can represent certain mass that is these Avogadro's number contain. Now, official definition, of course, of a 1 mole of a substance is the number of atoms contained in exactly 12 grams of carbon-12 isotope. And when experimentally these number of carbon-12 isotopes were determined, they were done in a way that they took 12 exactly grams of carbon-12 isotope, and through the experiment they counted how many carbon-12 isotope contained in 12 grams of it, and they came up with this number. Okay? So now, usually confusion, guys, rise when, let's say, I need the molecular mass, let's say, of CO2 versus molar mass of CO2. What's the difference between the two? So the molecular mass is the mass of 1 molecule of CO2, and we always use AMU units to represent that mass. In the molar mass now, we actually have a mass of Avogadro's number, and this is 1 molecule versus 1 mole of Avogadro's number mass, and that will be now 44.01 grams. But what is this mass in grams? That's a good question. So before I find out the real mass in grams for carbon dioxide molecule, let me just define again AMU. And the AMU is defined, and I did it before, guys, in the class when I had a face-to-face contact with you, is that 1 AMU is equivalent to 1/12 mass of carbon-12 isotope atom. And so we do the following: 1/12 times 12 grams divided by Avogadro's number of carbon-12. And so when you do this calculation, you're going to come up with this 1.661 10 to negative 24 grams, which will give you the conversion from AMU units to the grams. And as you can see, that it makes sense. In molecular mass of CO2, 44.01 AMU, and if we do the conversions, you're going to realize